Okay, so we finally get to do definition of the derivative today. Most of worksheet 9 is review. So at the end we talk about the new material, and that's the definition of the derivative. So I'm happy about that. I hope you are too. My pen is still not going to work for me though. Okay, so if you have any kind of arbitrary function, and we're talking about the derivative here, let's say we want the derivative right there. And so maybe we're thinking about like a tangent line right there. A tangent line kisses the curve without cutting through. Except there's like kind of an exception. For example, if you're at a point of inflection, it might cut through on some of these. Okay, but usually it stays entirely on one side of the curve or another. Okay, so you have an x value and you want to create a derivative. Then what you're going to do is you're going to take a point here, and you're going to be h units away. You're going to call this x plus h, and you're going to draw yourself a line between those 2 points. And the idea is, as this guy gets closer and closer and closer and closer and closer and closer, or it could have been coming from the other side, you can bring it from the other side, it doesn't matter, you're going to find the slope between these 2 points, and whatever that limits to is the derivative. So we draw these pretty far apart because otherwise we can't label everything accurately, but just imagine them being super, super close together. So this point would have the coordinates x plus h and f of x plus h, and then this other point over here is x, and f of x is of course the y coordinate. And then what would be the slope of the tangent line? Well, of course, change in y, so f of x plus h minus f of x and divided by x plus h minus x, but everybody knows that the difference between x plus h and x is simply h. So we'll just write it as h. Now you'll see sometimes the definition, instead of h, there'll be x plus delta x. I find that to be a waste of time. Okay, but in that case, if you see delta x, the delta x is seen as a single character, but if you wanted to square it, you would write it as delta squared of x, so as not to make somebody think you're saying change in x squared. Okay, but that's one of the many reasons not to bother with the delta x. The delta x is extremely useful if you have a delta x and a delta y, and you want to be sure that people know which change goes with which variable. In that case, it's really valuable. But if you just have one variable, you may as well just make h the change in that one variable. Then what you do is you take the limit as h goes to 0 of this whole mess that you just created. Okay? And that is lovely. And so what you normally have is whatever f of x is comes out, what I mean by normally meaning, in exercises that a teacher will give you. Then there's a piece that comes out here that, oh my gosh, looks exactly like f of x, because you do some algebra, you get f of x plus h times a whole bunch of other stuff. And then what ends up happening is you cancel out the f's, then luckily, if this works right, then you cancel out the h's, and then you're home free. So that's how the algebra works. And why did the algebra work that way? Remember, not because there's any reason why it ought to work that way, but those are just the exercises that teachers will give you. That's the whole point. There's tons and tons of things that take more steps and are more complicated, but we usually don't give them to you as exercises on the first day of class. That's all. Okay, so there are 3 classical styles of question that fall into this algebra category. And I'm going to break them up into 3 parts for you because those are the types of questions you're likely to see as a student. So like on web work or in the worksheet, you're going to see polynomials. You're going to see things that are equivalent to 1 over x, and you're going to see things that are equivalent to square root of x. Very little else will be given to a beginning student in calculus in interacting with the definition of the derivative for the first time. Again, this is a whole pedagogical thing. It has nothing to do with the way the world works. It's how pedagogy works. Okay, so those are the 3 types of questions you need to be able to handle. So let's start with the first one. Let's find the derivative of f of x equals 3x squared plus 1 using the definition. Okay? And so here's what we do. We already have f of x that's given in the problem, this piece. We don't need to create that. But let's actually figure out what f of x plus h is, because that's usually the most annoying part. So let's go ahead and figure that out. That's why we've been doing all these drills leading up to this. It's not just for nothing. It's because we want to make sure you guys got this, so when we move on, there's no train wrecks. Okay, so this is like 3x squared plus 2xh plus h squared plus 1. This is where you want to speed up the video if you've seen this before, because it's not terribly exciting the second time. And maybe it's not even exciting for you the first time, but I think it's pretty cool. All right, so this tells us, in this case, this is our f of x plus h. Now, the next piece I want to do is figure out the numerator, because I want to just actually take this apart one piece at a time. I find it easier to figure out the numerator first and then put all the pieces together. So I notice that this piece here, 3x squared plus 1, as I promised, f of x is somehow embedded algebraically in this expression that we're trying to create here. So we are lucky because all the remaining pieces have h's in them as promised. So we may as well factor out that h, because that's the thing we want to cancel anyway. And so then we say f prime, I'm going to go over here on the other side, f prime is limit as h goes to 0 of, now this is f of x plus h minus f of x, so I'm going to just dump this stuff in. It's h times 6x plus 3h divided by h, cancel the h's, let h go to 0, and the answer is 6x. Okay? So remember, whenever you're doing a limit, you first try this value just to make sure it's not a trick. But sure enough, if you put the h is equal to 0 in without canceling first, you get 0 over 0, which is a pain. You don't want that. You want to actually do something more clever than that. Okay, so anytime you have a polynomial that feels exactly the same way, it's just that all the different parts end up doing their own thing. Okay, I'm just gonna actually just wipe this stuff off here so I have a clean slate. And let's go on to one of the other 2 problem prototypes. Whoa, I meant to just get a pen here. All right, find f prime of x if f of x equals 1 over x. And you can make it 2 over x, or you can make it 2 over x plus 3. It doesn't really matter. The strategy is the same. So we always want to find f of x plus h first, right? Is going to be, well, it's not that exciting, is it? So now we want to subtract f of x so we can get that numerator. But unfortunately, there's no simple thing yet that cancels out. But remember what I told you, you're a beginning student and this wouldn't be given to you if there wasn't a cute little trick to get out of this algebra mess. So what do you do when you're adding fractions? We all know this trick. We always have to get a common denominator. Woohoo! Cancel, cancel. But then that's going to be h over x times x plus h, just like I promised, because I told you there's always got to be an h. Otherwise, this whole algebra trick is not going to work. So again, pedagogical stunt. We're only going to give you problems that are pretty easy, actually. So it's actually just seeing if you're paying attention and still can handle the algebra. So f prime is limit as h goes to 0, 1 over x, x plus h. And that now it's safe to let the h go to 0 and you get 1 over x squared. I feel like I'm missing a negative. Where did I miss the negative? Let me go find it. Ah, this was supposed to be a plus. So this was supposed to be a minus. Let me go tell you where the errors were. This needs to be a plus. This needs to be a minus. I missed the minus here, here, and here. So please fix that in your notes. I know you're taking copious notes because it's a video, right? And you can never find it again. That's a great thing about a video. If you forget what I said, you can just rewind it. So I forgive you if you're not taking notes. But what I recommend is if I say anything that you haven't heard before, or you don't immediately comprehend, you really should be writing it down alongside of me. I'll warn you now that the course is probably going to start moving more in that direction. So if you haven't been keeping a notebook, now might be a good time to go on Amazon and say, hey, maybe I do want a 3-ring binder or a notebook or something, because she started saying some things on that video that I don't think I can just remember now. I think I'm going to have to write some of this stuff down. Now's a good time to start writing it down, because now we're going to start in on the real calculus stuff, and we're going to do a little bit less of the review. I mean, I'll still remind you of stuff, but now it's going to be new, cool calculus stuff. Okay, and finally the last little stunt. F prime is equal to what if f is equal to the square root of x? I'm getting really lazy with the way I write my questions now. All right, so use the definition of the derivative. So f of x plus h, this looks really obvious. X plus h. Ooh, I'm really shocked. Okay, but then what do we do now? F of x plus h minus f of x equals, oh my gosh, there really isn't anything I can do with this. Of course there is. If there wasn't something you could do with it, I wouldn't have given it to you. But the point is now I'm going to do this crazy mathematics trick that you wouldn't have thought of. I mean, of course you wouldn't have thought to do this. This comes from years of practice and seeing the solution to these crazy problems. But that's part of the whole training in mathematics, is to learn what tricks work. So f of x plus h minus f of x actually equals, all right, so now remember, let's remind ourselves, a minus b times a plus b is going to be a squared minus b squared. That's the whole point. That's the whole point of multiplying by conjugates, whether it's a square root thing, conjugate-y thing, or if it's at the I, complex world conjugate-y thing. Conjugates come up all the time. So the square root of the square of the square root, minus, there we go. You're starting to see that I didn't lie to you. There really is a free x on top, and then we get x, get the magic h that we've been waiting for, that free h that we're going to be able to cancel. Okay, now we're going to go over to the left-hand side of the screen and finish up this problem. Y prime is limit as h goes to 0. I'm going to just go ahead and divide by h. If you don't mind, I'm not going to write it twice. And actually, I made a mistake because I was supposed to put the x here. My bad. I'm going too fast. Okay. And so y prime, now I can let h go in, and there we go. So those are the three things. You got to do the polynomial, the square root of the x, and the 1 over x, because otherwise, if you don't have those under wraps, then I can't really motivate the power rule very well, can I? So anyway, those are the tricks you need to know to get you through problem on the last problem on the homework, and maybe it's not even the last problem. Actually, it's only one of the problems on the homework. I think I give you a peek ahead for another question. I don't know. But all three of those are things I want you to know how to handle. Okay? And I think that's all you need for worksheet 10. Let me just pause the video for a second. Yeah, I think that's it. See you in class.